All right, well, we'll get started with the formalities, I guess, at least. My name is Ken Rimple. I work for Chariot Solutions. My Twitter handle for all of my Chariot work is @TechCast because of our podcast, the Chariot TechCast. It's been around for about a little over 10 years now. So I'm a host of that. I do the Tech Chat Tuesdays every week. You can see them over on YouTube at at youtube.com/Chariot Solutions. You'll see the playlist for Tech Chat Tuesdays. My main job here is director of training and mentoring. So I handle any kind of training that happens at client sites. I also do mentoring of different developers, both at clients and sometimes newer developers here. And I present at emerging technologies and newer technologies at conferences such as our own Philly Emerging Tech. And I've been working on projects since 2007 at Chariot. I have been around a long time, so I've seen, databases, client server, web-based stuff. I've worked in Java a long time, did a lot of single-page app stuff with Angular and with React, and now, most recently, in the last couple of years, I've been focusing on AWS platforming and specifically around Docker-based technologies. So that's a lot of my focus today. Chariot Specialties, we are a consulting firm. We do application architecture and development, whether that's single page apps or, server render apps, what have you. We do mobile application development, single page in React and Angular and sometimes Vue. We also are pretty heavily involved in some data engineering projects for data scientists. We kind of provide all the infrastructure and plumbing and processing of that data so they can be successful in their mathematical and scientific analysis. And we do a fair amount of cloud development and cloud platform work as well, both in Azure and specifically in my talk here, I'm focusing on AWS. We do run the Emerging Technologies for the Enterprise Conference. We've been doing that for 14 years, I believe is the right number there. And we've had speakers from all over the world talk about a large variety of subjects. So just a quick plug for that. If you haven't attended that, it will be virtual this year. And hopefully this will be the last year we have to make it virtual. But you'll see an announcement on phillyemergingtech.com about the new date for that coming up in a couple of weeks. We also sponsor user groups and other conferences as well. All right, so let's talk about what this talk is going to be about. The goal here is to give you a recipe and some ideas for how you would approach a project, a greenfield project for 8 weeks to build it and deliver it in AWS using Elastic Container Service and CloudFront. Those are the primary pieces that get deployed in these projects that we run into. We're also going to make sure that the developers start from the beginning working on the same type of platform. So we're going to leverage containers and Docker for local development, and then of course deploy it to AWS with ECS, which is the Elastic Container Service. You could take the same set of concepts and use Kubernetes or even serverless as concepts. It's just more organization of the project tasks and some of the things you'll run into specifically around ECS and so on. And we'll make sure we cover some of the key things that you have to wrestle with so you're aware of them as you go along. All right, assumptions here is that in this project, that's fictitious project we're talking about here, it's kind of a synthesis of a couple of the ones I've been on. But one of the things is we're assuming that the initial upfront user experience work and basic wireframes have been created already, that there's a person who's going to be shepherding the project in an agile perspective with issue tracking and so on. The documentation will be committed to the project as markup code like Markdown or ASCII doc. And the reason for that is it gets versioned along with the code, so it's not instantly stale. And I find with a lot of these projects, there's a lot of promise of cloud being quote unquote better. Cloud is different and cloud management is different. Therefore, and every project has its own unique challenges. So document the novel, and we'll talk that a little bit later. And so your first week here is the beginning of the development effort. Also, your project is not mine. So, this timeline is completely arbitrary, assuming 4 features that are reasonably solved in 2-week chunks. It's a greenfield application. It's not going to fit every circumstance, but we just wanted to kind of factor this into something relatively digestible as a concept. And you can certainly scale this up for larger efforts into longer numbers of sprints, more development teams, and so on. And when I say to production, I mean that it is deployed in a production environment and user testing has already begun and getting close. So this is my take on 8 weeks of project time and what 4 developers would be focusing on. And remember, migrating an existing application, there's a whole bunch of other considerations. And so that's not even part of this discussion here. But you can factor some of that stuff in from this presentation in the way you structure a rewrite as well. Okay, proposed patterns here. We're using Docker, as I said before, and or local servers for local development. For example, your web server might be running like the runtime for your web single page app, like Angular, ng-serve, or React, create React app services. So your web app might be running locally on your computer, but then your app server, your database is probably going to be in Docker locally just to be productive and look like what the end platform might end up as reasonably. AWS development is going to all be through configuration as code tools. And I'm talking specifically about things like CloudFormation, Terraform, or the Cloud Development Kit, CDK from AWS, any of those three. I am not currently on this talk focusing on Lambda application. Specifically, I'm not talking about Lambdas because that is going through some transformation and some improvement. So I think the tooling for Lambdas within a year or two are going to make it even more like the Docker way of doing development than they are now. Specifically, look at some of the announcements AWS has about their own Docker containers for running Lambdas locally. That should be something interesting to you if you're researching that. So we're just specifically looking at writing application servers in Docker, but you could apply it to other things like Lambda in the future concept-wise. We're also assuming you're going to secure your application. And so for that, we're picking Cognito as the thing we'll discuss. Cognito is Amazon's security system. You could use something else like Auth0. And in fact, we've had other projects, for example, using Kubernetes and Auth0 instead of Elastic Container Service and Cognito. So it just depends on the client and depends on the person you're working with, your subject that you're deploying for, what their infrastructure is. We're assuming Cognito, and we're assuming a JWT token, JWT, for security. We're also assuming that the application will manage the data roles. So in other words, as you're logging in as a user, as an administrator, as an admin, whatever, you're setting up roles in your database. You're not really using the more advanced Cognito identity pools for this, just because in smaller applications it's not warranted. All right, from a team perspective, what would be a set of good required skills for a team to be successful? Now, this is not to say you can't do something, but if you're talking 8 weeks, you need people with these skills. They don't all have to have them, and they can be specialized. Not everyone on a team can know everything in a short project. So you're going to assemble a team that some people are good at some things, some people are good at others, and they'll gravitate towards those tasks as their primaries. So in that case, you're going to need front-end expertise. So someone on your team should be familiar with an SPA framework like Angular, React, or Vue. In the last 2 projects I've worked with, I have served that role as an advisor to get things started. So for example, the first one of those 2, it was a React app, and I had just been doing a lot of React training and some consulting. So I helped stand up the beginning of that and then got out of the way as the developers really shaped it for us. And in the prior project I just got off of, it was Angular based. But that's not to say you can't use something else. The bottom line is it should not be their very first time using a single page application framework if they're going to build something in 8 weeks. So just take that for what it is. Also, I wouldn't have, unless you have the resources and the money and the budget and the time, I wouldn't necessarily build a CSS from scratch. I know that's a debate we even have here at Chariot. Sometimes we have some really talented developers that do CSS and are in good control of it, and there's enough scope to do that. But for the average developer who's standing on board on a single page app framework, picking a framework for CSS like Bootstrap, Material, or something else is going to save you a ton of time. Also, someone on that project who's doing this is probably going to be comfortable installing libraries, NPM, packaging things. So you're going to be installing libraries for AWS SDK, for example, or Amplify. And so you'll need to know how to do that and be able to call web services with a web service framework library and manage tokens. So that's good front-end expertise. A lot of that has nothing to do with with AWS itself. It has to do with being good at front end. So that's an important skill to have on your team. Someone who's good at application server development to write the REST endpoints, or if you're using GraphQL for that matter, someone has to build that stuff up. So hopefully one of your team members is stronger in that, whether it's a Java Spring Boot app, Node Express, Python Django, Ruby on Rails, I don't care what it is. The point of this talk is that as long as you can express that server in a Docker container, then you can use that platform. And that's the benefit of using something like Docker, is that you could write a RESTful server in whatever makes sense for your organization, as long as you know how to tune that and launch the appropriate number of Docker containers in production. Also, here's a little tip for you. If you are doing development on AWS, there are certain, not necessarily limitations, but things you'll have to follow. For example, on one of my prior projects here, we were doing CodeBuild, and our project itself, we were building it on JDK 14. But the CodeBuild work was being done, and it runs on JDK 11 under Chariot. So I had to actually take some of the code I was going to call from the application and slightly rewrite it so it didn't take advantage of JDK 14 features, so that I could run the CodeBuild code to kick off things like creating users and such in my application. So you may just want to double check that the services you're picking support the language version, the database version, the features you're looking for before you begin going down a deep dive in those. It's always a good idea. I'm going to launch my slide notes, so just bear with me here. There we go. Okay. From a Docker perspective, I feel that, you know, your development team may not all know Docker to begin with, but by the time learning the basics, and there's not a ton that they really have to know. If one person's responsible for it, they'll all get used to firing up Docker containers. And the easy way to coordinate a group of Docker containers together is to use Docker Compose. Docker Compose lets you connect a stack of Docker resources together, different Docker server instances. So you can start a local database, a local application server. You can run your migrations tools, which we'll see in a minute, and do all of that from Docker with a simple command, Docker Compose up. Someone doing that work will probably at some point need to build a Docker file. And the reason you do that is maybe your application server has custom things it needs to have installed. You know, maybe you want to customize the way it starts Node and things like that. So you may end up building your own Docker instances. Someone knowing Docker files can help out in those cases. And then ultimately, we're doing this because we then can target running this thing in Amazon's Elastic Container Service, which is essentially a Docker runtime in the cloud. So your Docker skills get translated right up to production success in Docker in the cloud as well. Then again, quick proviso, we're not focused on Kubernetes. Same concept, though. You're building Docker images that you then deploy through Kubernetes instead. And EKS, Elastic Kubernetes Service, is that service in Amazon. So you could do that as well. And we have. If you have an AWS expert that's going to be joining the team, these are the types of things they're going to do. And I will provide these slides in that Slack channel when we're done today. So for example, building up your Amazon CLI settings and setting up your profile on everyone's workstation, setting up the accounts, making sure everything works. One person can run with that while the others are just building things in Docker early on. You're going to be using this configuration as code, CloudFormation, Terraform, CDK to set up your resources. You're going to be doing roles and policies to set up the right permissions for developers and for the runtime, and then for your provisioning user, which we'll talk about later in the presentation. The AWS engineer is going to be setting up the web application, the web service, and that's going to be running through an S3 bucket. And potentially you're going to be sending that out through CloudFront across different regions to replicate it, to make it run quickly. Oops, sorry, hold on one second. Sorry about that. That was a rookie mistake on my part. I did not turn off my audio. Okay, and then we'll deploy an ECS, so you'll need to learn how to configure that using CI/CD with CodeBuild or Code Pipeline, configuring security with Cognito, and then ultimately one of the things that you'll end up using is Secrets Manager. That's one of the ways you can store secrets for your application in a secure way for production. So those are the kinds of things that an AWS developer will be doing. So if you're looking for team members that have some AWS skills and you're able to select one, check to see how many of these they know, and the ones they don't know, have them brush up on before they get started. And of course, getting certified. You know, AWS is so new. It reminds me of 20 some years ago when I was doing Java for the first time. It's such a novel and new thing for a lot of people. Getting that certification can help you get a good baseline view of the terminology, the lingo, the way the services work. So I'll just throw a plug out there in this case, because it's so new and you don't find as many people doing it. I think about 4% of all businesses in the US are using AWS. That's a sizable number, but it's not as many people not using it. So the knowledge hasn't really seeded itself, like if I told you to build a servlet or a Ruby application today. So certification can help. All right, so our divisions of labor here. Assuming we have a 4-person team, one team member focuses primarily on the AWS work, and you'll see that there's stuff to do up front, there's stuff to do all the way through the project, and there's a lot of prep work for production. 2 developers would probably focus, and this is how it's been working out for us for these smaller projects. 2 developers will focus and pair together and work together on the application features as well as the web front end. And then that 4th team member can focus mostly on the AWS APIs themselves, setting up like different services in AWS. Also, I'm assuming here that one engineer is taking the job of something like Scrum Master, so they can manage, the task workload and such. From a timeline perspective, assume we get our pre-project inception planning out of the way, which we'll talk about in a minute. Our first sprint's going to focus on getting the script set up to manage AWS and CloudFormation or what have you, getting that Docker config launched right away, the application stack set up, and beginning feature development. So that's the first 2 weeks. The second 2 weeks, now you're building out more of the AWS resources, like if you're using S3 buckets or email or what have you. You're improving the data model of your database as you move along. I'm assuming here a relational database. It could be something else. It could be Dynamo. But for the sake of argument, let's call it a relational database. And so feature development is underway at that point, and 2 of the developers are heads down doing feature development in the second 2 weeks of project. Sprint 3, now you're really cooking. So at that point, you're going to do a production install, hopefully early on AWS. Since it's a greenfield application, you want to get a hold of a production environment where it's going to ultimately land. You're going to want to do that, get it installed, set up a CI pipeline for future efforts on this project, continuous integration. So you can do things like when you check in, automatically do a build, that kind of work, and the feature development itself. And then the 4th one of the most important tasks on these projects, and this is important to me as someone who has to live with the platforms that people are developing, is you need to provide a platform guide. As you're learning what you need to do to set up your application in the cloud, and as you're doing it for your developers and for your QA instances and things like that, and demo instances, you should be documenting that. So by sprint 4, you should have something to hand over to the production team that says, hey, if disaster strikes and we have to load this thing from backups in a new region, what do I have to do? And what are all the novel steps I need to take? That platform guide is essential. So we'll talk a little bit more about that at the end. And then, of course, production delivery, completing all the features and building any web tests that could fit into the cycle. And the other thing here to keep in mind is you really do want to deploy to AWS as soon as possible. The sooner you get things running through configuration scripts, the quicker you will get it figured out and ironed out at the very last minute, trying to do things in the console. Worst thing you can do in these projects is, jockey the console and take over the console and control it, and then try to remember what you did later. Use these scripting tools to do your production configuration, and even use those for your developers to access. All right, so that's the timeline. And week 0, before this starts, get everything out of the way that would take time. Don't waste your developers' time setting up the Git repo or Jira or anything like that. Set up your AWS accounts. We have some blog entries I will put into the chat over on virtual events at Chariot. There's 2 really good articles from Keith Gregory at Chariot, who's our AWS practice lead, on setting up accounts and managing your credentials, and I'll put them up there after the presentation is over. Excellent guides. So you want to get that all set up, and you want to kind of smooth the landing into this for your team. Another thing that comes up a lot, and we see this in the consulting capacity, but you'll find this in your own organization. Don't just assume you know what the tooling is when you start building. If you go 4 weeks in building in Terraform, and your company doesn't actually use Terraform anywhere else, they're not going to love working with your platform. So my point being, find out what your organization is using for these configuration tools if they're already on AWS for other efforts, and follow them. And, if not, if you have no other selections, CloudFormation is kind of the de facto way of configuring AWS. That's one thing you'll do. is maybe pick CloudFormation. But if you have other things, you want to kind of follow along with the other teams and take advantage of their expertise in these platforms as well. Another debate is what language to write the app in or what database to use. Just try to figure some of that stuff out up front so your team isn't running long debates about databases or programming languages or web frameworks before you start coding, because forget 8 weeks at that point. Forget 20 weeks. It depends on what you end up arguing about, but you could get into some really crazy debates and waste time. Find out any additional security limitations or concerns. We just had a customer, one of the requirements was when you log in, they wanted to serve multiple clients and they wanted to be able to have a different web URL for each client. So we ended up having a slightly more complex Cognito configuration for that and domain design configuration for that. And there's an example of something you need to kind of know up front, or at least discover up front in order to script it early on and take care of it. And other things like integration points with other systems. Do you need to copy files somewhere else? Put things on an SFTP site, or, integrate with an S3 bucket they already have for something else like a data lake. Find out early on and try to, throw those in as issues to integrate in your issue tracker. Okay, so let's look a little bit more in detail at Sprint 1. I have these little diagrams here that roughly talk about the things you're doing. So the first row here is what the infrastructure Docker person would be working with. Someone who's taking care of Docker and local development and like AWS API coding is one person. So that person would be setting up your Docker application stack and then moving on to setting up your database, making sure that you've got database migrations tools to modify your schema as you move forward in development, and making sure your core libraries are settled, things that you need are settled, so you can get things done. And that'll all be kind of like to support the effort of the developers locally as they're using Docker. So the very first thing they need to do is get Docker running, get an app running, and move. And we'll talk about that in this set of slides. The AWS person is going to start really at the very beginning, setting up the base AWS platform so that as soon as they have something working in Docker, they can start getting ready to deploy it in AWS. You may not deploy it by week 2, but you'll definitely be close in Sprint 1. And then the two developers working on the application itself can pair, get the single page app configured, get the navigation model, how are we doing links for routing, things like that. And we'll talk about that in a little bit, choosing a CSS framework and a UI and such, and roughing out some of the first feature. So in terms of details here, nothing needs to be perfect for that initial project skeleton. You're going to perfect it over the next 8 weeks. You don't need super integration between things. I'd say the only thing you really need to integrate is the web making a call to the application at this point. Sure, eventually get the database worked out, but the very first thing you need to do is have your front end be able to call a service on your node engine and then get rolling. Don't worry about security. Don't worry about perfected UI design. Simple, modest hello world UI. Then the rest of the sprint can be roughing out features and having meetings with the clients to figure out things they need as well. There's a lot of hand holding up front in these projects just to make sure you have some decisions made. And this gives you some room if you get this done up front. Another tip, we are talking about using Docker, but let's talk realistically about what you would put in Docker. Your database definitely can run in Docker because locally you don't need to install Oracle. You don't need to install Postgres or whatever. Just go ahead and throw a Docker container up and get it started. For example, here, all I need to do to boot a Postgres server is a couple lines of code, right? Here's a Docker compose file for a database. And that's that plus a volume statement at the end, which is literally like 2 lines on line 41 to 42 there. That's all I need to start a Postgres server. And it's going to be similar for MySQL, similar for other ones. There's a Docker container for these things. Now, you run your database on Docker. You'll ultimately be running your application server on Docker, and you might do that early on, and that's fine. So there's an example of setting up a node-based instance there. But you don't need to run the application from the web perspective there, meaning like running Angular or running React in Docker. And the reason being is you want to run it in an interactive developer mode where you're constantly hot reloading the front end as you're developing the features. So you have instant, snappy performance as you're learning what you're building and you're tweaking things. So you want it to be able to automatically reload. You want it to do hot deploying. You can use local debugging and tooling. In the end, you're not really going to run it in Docker anyway. You're going to copy your website to S3 and serve it out of S3, or have CloudFront integrate with S3 and serve it there. So you don't need to run your single page app in Docker. Don't waste your time. From a UI layout perspective, pick your CSS framework early and stick with it for the project. It's only 8 weeks. You don't have time to reinvent the wheel. And roll out some basic initial UI for the single page app without tuning everything. So you just at least have the shell of it there. Maybe you grab a default, 1 column or 2 column layout and navigation pane just to start with. And then you can work on the prettying it up later. The key features you want to nail up front. How are you going to switch between different views in the single page app? So this is typically done through routers. And so Vue and Angular and React all have a client-side routing system to show different pages. And just go ahead and set your routes up and stub the views out. Just get them started. You should probably have some basic header and footer. And you should probably think about a sign-in button, even if it doesn't do anything yet, just so you have a place for it. So figure out where that lives and put it there for now. Again, it doesn't have to be perfect. If you have no other choice for CSS framework and you're debating 5 of them, I would say go with the simplest one you can pick that will be reasonable. It usually in our teams ends up being either Material Design or Twitter Bootstrap if you're starting from something that's not your own. Bootstrap is actually pretty thin and simple by default, and it's pretty popular. And there are variants on it for Angular and React and Vue. So if you have nothing else to choose from and it's an internal app that you're going to use in your organization, that's a good one. I find a Material Design to be a little more sophisticated and it could take longer to tweak, but that's just my own personal perspective on that. From your single page architecture infrastructure, a couple things you need to nail also. You need a web API to call web services. Now, Angular has one built in called the Angular HTTP service, but for React and for Vue, you have to go picking an HTTP API to do the web service calls from. Make sure if you pick one that it allows interception of the API calls. So as you're trying to do a web call, you should be able to have a hook in there to make sure that you're actually logged in. And they're called interceptors, for example, in Angular. And also Axios has the same concept. The reason for that is so you can make sure you're actually logged in and you can provide the login authentication token when you do that. So that's important, is to nail that early on because you're going to be using it very early in the process. Build a simple API calling layer in your app. And this is really important in my mind. I have found in multiple projects now that instead of worrying about different domain names for your app server and where your web hosts are, like for example, www.foo.com and api.foo.com, if you go down that road, you have to actually set up these things called CORS headers. And CORS headers basically tell the browser, you are now allowed, based on downloading my app from www, you're allowed to now call API calls over in api.foo.com. This is always a pain in the rear end. And so what we found is just making a relative link to a /API directory in your single page apps call. You can proxy it early on in your single page app to run your Docker container for Node or Spring or whatever. And later on, when you deploy with CloudFront, for example, CloudFront has this concept of origins where you can say, if I'm going to this path API, go to this server behind the scenes. And that server can be an ECS Docker container. So you can use the same technique both in local development by having your local web server that runs your front end hit the API virtual path, logical path, and then that path will go to Docker. But then in production, the same thing will happen and it will point to the ECS Docker instance. Next thing you'll need to deal with early in the project is get your database set up. And realistically, like I said, you've got a very easy way of doing a database. Here is Postgres in Docker Compose. I literally just slapped that in and had a Postgres container in a minute and a half. So some things you're going to do, and you're going to do this a lot in Docker, and it's going to translate directly into production benefit, is you're going to use environment variables, whether they come from a file like .env, or they get embedded, or they get pulled in from an additional file. Just for developer settings, you're never going to put things like your AWS keys in here, for example, but you are going to do things like make up some, usernames, passwords, and settings. and you're going to use those in each of your containers. So for example, the app server will, point to the host name, and Docker gives the name of the host by default as the name you use for the Docker container in the config, but you can also name it separately. So I'm pointing the DBMS host, which is Postgres 12 here, and whatever user and password and database I define when it creates it are the connections I'm using when I point my app server to it. And in general with Docker, you're going to send environment variables into the Docker containers that contain the information needed to connect to other Docker containers. That's how it works. In the end, instead of using a little .env file, which is what I'm using in my example, which is just key equals value, you'll use secrets manager, and you'll use a CloudFormation or Terraform or CDK configuration to inject all those settings as environment variables from the secrets manager service into your Docker containers at runtime in the cloud. So you start early with environment variables and you end up with them in production. Very useful to do. So again, run your relational databases. Don't run them on AWS for the developers because that costs money, real money. RDS in the cloud can cost you, 50, 100, 200 bucks per person a month, depending on what you pick and if you over provision. But if you run Docker locally and run Postgres locally for Docker for your development, then you're paying nothing for the databases while the developers are doing their work. DynamoDB even has Docker containers. So if you have someone that wants to do a lot of iteration and experimentation on Dynamo, and there's an app they're going to put Dynamo in, there's a DynamoDB local that Amazon provides as either a Docker container or a standalone service that also can run. And again, use environment variables for your database connection settings. It's very useful. The next thing I'm going to recommend is you use a tool for managing your schemas. And anyone who's done Ruby on Rails work or Grails in the past, or Django, I guess, has used migrations. And these are just scripts that over time build your database up from step to step to step to step. And so I recommend a migration tool that we've used on a number of projects now called Flyway. It's free, it's open source. There's a commercial version, but you generally don't need it. And here's Flyway in a nutshell. Where is it on here? Migrations. So this little chunk of code here, and I don't expect you to memorize it. Point being that there's this thing called Flyway. It's a Docker container that runs actually a Java jar. And that container connects up to your database. It looks at a table that it creates called, I think it's called migrations. And it will then take a look at which migrations have been applied. Now you mount a folder. So in my project here, I would have a DBMS folder and a SQL folder underneath it in my Docker directory, my app project directory. I'd put particular SQL files in sequenced order by a date stamp and name, and they get mounted in the container as Flyway SQL. And when it starts up, it looks at them all, looks at the migrations table, and applies what you don't have. And this is very, very useful. So I recommend you do this and use a tool like Flyway, if not Flyway. And then you'll ultimately end up running this in AWS as well to provision your AWS database instances, because you've already got the infrastructure built. So you build it early, now you have it for production as well. All right, from the AWS side of things, you're going to pick your configuration tool and you're going to start building your scripts. Just to give you an idea of what some of these look like, I'll just show you two of them. So first would be CloudFormation. CloudFormation, and forget the long names here. This is just because I was hacking around some experiments, but this could be like, my VPC. CloudFormation is a YAML-based tool, so it's indentation-based text tool, and you can run your CloudFormation. You can feed it input variables, and like settings you might want to have for any individual deployment, and it will apply those and it will set up the infrastructure. So in this example, this whole thing is a little sample stack that I'm working on, which I will publish eventually, and I'll put that in the virtual events when I have time to actually complete this Hello World all the way through. But this is a CloudFormation example of the way you provision things. One of the things we're provisioning is a virtual private cloud. Your apps in general will run their backend services in private network addresses in a virtual private cloud. And if they need to get to the internet, they will use a gateway in a public address, public IP address range. And this thing here is beginning to provision that. So you'll see a VPC, You'll see subnets being created. All of this is CloudFormation. And this is just my CloudFormation. And there's your network gateway, my NAT gateway, and so on. So it looks like a lot. I'm mentioning it and showing it to you because there's a lot going on here that gets provisioned. And so that's why it's pretty much a full-time job for your AWS infrastructure person to get the stack up and running. But that's roughly what it looks like for CloudFormation. But you may look at the CDK, and the CDK is Amazon's code-based, and you can run in Java, in Python, in I forget what else, but in JavaScript and TypeScript, and this is a TypeScript example. So in this one, let's just look at that same setup. Let's look at the VPC that we just saw, which had a whole bunch of pieces of code involved in it with sensible defaults, and those two lines do that same amount of work. In fact, I took the output of this CDK script to give you the CloudFormation sample. So that two-liner, not that I'm selling you CDK, but it gives you an idea from a development perspective how quickly it would be to get it up and running. Everything to, just trying to find the end of it. Right there. Everything to this, 246 lines. There are sensible defaults in order to build out your VPC. So something to consider is that you might find more efficient and quicker ways to build this stuff up. If your standard in your group is that you'll end up with CloudFormation templates, you can start iterating with CDK and then generate the CloudFormation and go back and do commenting in it to make sure people know what it is. So that's an option for you. So you definitely want to start with these, CloudFormation scripts or what have you, and you want to version them alongside of your code. They go up and they get released along with your code with the same versions. There are templates out there for all of these. So you can find, for example, the CDK has an excellent set of templates. There's a lot of samples for CloudFormation, and of course, Terraform has theirs. So you can use those as a base. And, we certainly can assist in those things as well if you're just starting from scratch and have never done it before. And break your configuration up into several chunks. So you might have like your infrastructure set up, your VPC and some security roles and things like that in one script. And then you might have, resources for storage in another script. And you might have your container in another script, your ECS container. And you may have your web assets in another one, just so you can find things easily and not scroll through 7,000 lines of YAML. And again, do not provision in the console. If you're writing code against stuff you provision in the console, that should be a short-term thing until you can add things to your infrastructure scripts. And you should never say, I'm committing a feature without having the infrastructure script to produce it. The other thing that will come up from the AWS perspective is there's basically three personalities that you're dealing with, so to speak. There's the provisioner that's running the CloudFormation. That's that AWS expert that's getting things rolling for you. Then there's developers using some subset of the services. Remember, the developers are running in Docker. They're not necessarily running in, they're not really running the full application. They're not running ECS, for example. And then there's the production deployment, which needs access to all of the things you've created, but doesn't need create rights because it's production. So you will do this by granting permissions to Amazon's IAM roles. That's the account management system roles. And you're going to assign those roles then to the different personalities, the connections that need them. So you'll create IAM users for those with CLI users that can actually execute these pieces of code or run these services. In production, your ECS container will take on one of these personalities. So you will assign the role with the permissions you need to the ECS container, or at least the permissions thereof. And as you're building these services up, sometimes, it makes sense to just directly call something. For example, your database, you're going to use, if let's say you're doing Java, you're going to use JDBC in production, in development. You're not changing that API, right? But if you're going to store things, or send an email, and you haven't settled on what service you're going to use for sending an email, maybe, some of the company are saying you need to use their SMTP server, and others are saying, well, go ahead and provision SES. You probably want to make a method called send mail and wrap everything behind that so that you don't embed SES code, for example, all over your application. And early on, if you don't have any answer for that, you can stub out that feature, make a fake response, and keep moving in the user interface elaboration. If you know it's an asynchronous service, on the server, make it something asynchronous and give it an asynchronous answer later. So you have an easy way of plugging an update in later when you wire it to the real service in AWS, right? So you can stub out those AWS calls to get some customer feedback in the UI, while then the API developer is then working on integrating the AWS features. And that works out great for keeping things rolling. So at the end of this sprint one, and this is like, there's a lot in sprint one, the other 3 sprints are shorter amounts of things to talk about, is you've already set up everything you need to get going, your Git project, GitHub shared repo, your versioning, your documentation folder in the project should be there. You should be putting things in as they come up, like setting up a user. How do I set up a developer? How do I onboard somebody? You should document that when you do it, so that if someone needs to swap off the project and someone else comes in, they can look right in the project's docs and say, oh, here's what I do. It's better than putting it in a wiki, because wikis aren't easily versioned and they're easily able to go and become old. Whereas if it's in your software, you're probably looking at it when you do your commits and code reviews. Your basic project layout is there. You've got a simple front end calling an app server, maybe hitting the database. You've got your database booted in Docker, and you've got a schema migration strategy with something like Flyway. So now you can iterate features, and you've got your accounts set up and your developer tooling figured out. So that's what should be going on, and you should be well on your way for the first feature development. Now we get to sprint 2. Okay, so for sprint 2, we are now working more on the AWS configuration, adding more features to it as the features in the app need them. We're also going to be focusing on things like security with Cognito and setting all of that up. So there's a fair amount of tasks in sprint 2 that are infrastructural as well, but you're going to see that you've got more work you can do in parallel. So for example, the 2 web application developers can focus on different things, and they can work on 2 features at the same time. But again, we're going to focus on that Cognito, security configuration, iterate the services. The Docker app, early on, you'll want to establish that the Docker application should be able to call the AWS services. I don't have much in here about that, but the way that this works, and you can look at the different SDKs from Amazon, but the Java SDK for Amazon looks at a number of different settings, including environment variables. So one of the environmental variables it looks at is, what region am I looking at, AWS region, and it also looks at AWS profile. And so you can point it to your desktop's profile in your local .aws folder. So once you set up your CLI, your command line tools, and you set up a profile in your command line tools, you can have your Docker container injected with that profile information and be able to access that and be able to call things. And you can actually inject. I guess you'll need actually, and I should speak better about this. You may need to pull like keys in to your Docker container and inject them in environment variables, but don't check those into the project. You can refer to those in your home folders .aws profile names and key names. All right. And I could talk more about that in the chat later if you're curious. And your application development should be underway. And as you're working on AWS, you're going to find features. And the first thing you want to do is say, are these features solvable by some sort of AWS service that I can use that will make my life easier? Or do I want to keep them in some sort of library or feature that I install myself? So keep in mind, whenever you pick, if you pick an AWS managed service like SES for email, like S3 for storage, they manage that. They keep the uptime. They take care of it. If you're going to be installing an EC2 instance to do that, you own it. So just keep in mind, whatever you pick, if you pick managed services, you're giving up a little bit of quote unquote freedom for a lot of stuff being handled for you. So there's that push pull there. And everything else, for example, you're going to need a database. So you're certainly going to set up a database in AWS, and we're going to talk about that in a minute. And some are less obvious, and I want to point this out early on. Figure out your monitoring and logging as early as you can. You're going to probably want to use CloudWatch. Maybe you'll use Splunk instead, but you're going to want to use CloudWatch probably for logging. And so you want to set up your logging. Docker containers automatically output logs to CloudWatch, but then you can control where they go and how they are processed. You maybe hook something else up to it to sip it and to index it. These are the kinds of things that the AWS infrastructure person can work with, or work with the production team to identify what they're going to do with the logs. Maybe they want it in JSON format. So then in that case, you want to make sure your logging outputs in JSON format so you're ready for them when you integrate in production. From a database perspective, this is the time to provision the AWS hosted databases and make sure you have that settled, because you're going to be soon deploying some features to test for QA, for your own internal staff, and maybe for the customer as well, for your client, for your production users. So RDS is probably the one you'll end up using in some way, shape, or form. That's Amazon's relational data services. There is a database you can serve for almost every database type in RDS that you run into. RDS itself is provisioned, and you say, I want this many working processes, and I want this many instances, and I want these structures to be kind of preloaded for me and ready to go at any moment. And that means you're going to pay for that. You can also consider Amazon Serverless Aurora, which is a subset, I should say a separate RDS service. What that does is it ramps up and down the actual processing engines, much as the way that Lambdas do, or if you're using ECS, you're ramping up and down Docker containers. But think of it as like a upperly scalable, at a moment's notice, amount of database resource to apply to your databases. So processing resource. So what this means is, if you've got a low frequency amount of traffic, for most of the time it's idle, but you get spikes in the morning, spikes in the evening, maybe it's a timesheet application or something like that. If you're not using that app most of the day, Aurora won't be charging you anything. So what you're doing is you're trying to find a mix of instant on power from RDS versus relatively quick start, and I was not able to notice a really slow startup. It's not like there's a huge latency to get a connection out of Aurora. There is some, but it's not like seconds or even a second. But you're paying then for idle time in RDS, whereas serverless Aurora can save you from paying for the idle time. This is also great if you're going to do a development database and you're going to demo it periodically, but 90% of the time it's shut off. Use Aurora, serverless Aurora. And this is the time to start working on your application security with Cognito. Cognito, you'll be creating two things at minimum. They have something called a Cognito user pool. The user pool is a pool of users that you connect through an API. So you're defining the users as web identities, basically. And you'll have usernames, passwords, password rules, expirations, all that kind of stuff. That's all where that lives. So you'll set up a user pool. And then for the clients that connect to it, you'll set up something called a Cognito user pool web client. It's a property in there. And you give it an ID. And the client APIs, such as AWS Amplify, get configured with the pool information as well as the user pool web client ID, so they can connect up and do authentication, change passwords, log out, that kind of thing. And so administrative parts of the API can provision users. And again, that's through the Amplify Auth SDK. And that's the primary way that you would do that for either web or mobile applications. Also, another task you'll need to do, and if you don't do it in this sprint, you should be doing it by the next sprint, is, the way this normally works is the web client, let's say you're running a browser that hits the web app, and the web app downloads a React application. Now your React app is running in your browser, you click login. Okay, at this point, you are communicating directly with Cognito at that point. And so because you're communicating with Cognito to do the authentication, you're going to need then to, on the server side, when you send a web service request up to your application server, like Spring or Ruby or Python or JavaScript, you need to make sure you inspect the JWT token and the JWT token, and make sure that you verify that it came from the Cognito server. And there's an article here. I'm just going to dump this thing into. I'm putting this in the Slack. is a little article in just kind of getting started in verifying the JWT claims. So for example, in the claims, one of the claims is going to be your identity in Cognito. So that's your unique ID for your login in Cognito, your web login. And that's what you would use to link up in the database with your logical roles in your application. So that's one of the things you'll do, and you can start that in this sprint. So again, Cognito has user pools that provide authentication. There are also identity pools. These are really if you're going to do serverless applications and you want to have rights to different lambdas based on people signing in as different roles in the identity pool. So in that case, if you're going to do that, then that's when you'd build an identity pool. But you don't need an identity pool because those roles they have there are IAM roles. And usually in these smaller applications, the roles can be database driven. So a user pool is what you'll focus on first. And you may back into using identity pools, especially if you do a lot of lambdas, but back into it, don't start with it. All right. So, and then we'll have more feature elaborations. So now while all that infrastructure is being worked through by your infrastructure developer and your provisioner, you're going to have UI elements being built. So, you're at the point now where you've got a database, you've got migrations, you've got an app server, you've got a web application. So you're cooking, right? You're at the point where you're getting things done and you've got a navigational mechanism, everything's good. So you can be elaborating, finishing up feature 1, starting feature 2. So at the end, you'll have the developers using AWS services. You're working on a stack that on AWS, including a security and database mechanism. You'll have a better UI because you'll be elaborating that with your 2 web developers. You'll have some navigation filled in for different features. You'll have Cognito integrated. Your major feature, the first one could be delivered and demoed. Even if you demo it on Docker with a Zoom call at first, that's fine. Ultimately, by the beginning of Sprint 3, you should be starting to deliver things in AWS as well. All right, so you're gaining velocity in Sprint 2. Sprint 3, now we're going to focus on production. That infrastructure developer is sewing up a lot of the features needed, but the AWS provisioner is now going to be starting to get production readiness going. So the rest of them can focus on features, hopefully. So by sprint end, we're going to be done with feature 2, features 3 and 4 are in progress. And the thing you're going to focus on as the infrastructure person is the platform installation guide. Any scripts to run, and you want to make sure you start running these things in the cloud and reviewing them, especially with the production team, so they know what they're going to be assuming when they get into their role of managing the application. And you should have it deployed in both development and production accounts by the end of this sprint, if you can. The goal is get all the weird stuff out of the way early to save stress at the end. All right. So your developers, nothing new here. Just keep doing what you're doing. This would be the time to set up a CI environment. Some developers really like Circle CI. There is some support. I did some searching because I don't really use it much, but on AWS, they have support for it through Terraform. But realistically, if you're going to do things in Amazon, you're probably going to use CodeBuild and Code Pipeline. All 4 of these tools work together. So like the Code Pipeline manages things that are being stored in, you can, by the way, use Git. You don't need to use Code Commit. Code Commit's like a GitHub, private GitHub. But you can have Code Pipeline pick up when there's a commit to your code, run your code build, and then deploy it in the place it needs to go, like in a Docker container or copying files up to S3. And that runs natively in AWS, and it can run inside your VPC, so you don't need any weird special tricks to get to your resources. You're going to be documenting your installation steps. So for example, there are novel things. People think, oh, if I go to the cloud, there's just these scripts and they're just going to take care of all the provisioning. And there's no operational, interruptions that happen. That's absolutely untrue. In fact, there's nothing but weird, novel things that happen when you're dealing with deploying to the cloud. So every time you find something odd, throw it in a document that ultimately becomes part of the installation guide. For example, when you set up your certificates and everything, you may have to verify a domain by hand in Route 53 and set it up and pass that into your scripts, because you need a validated domain in order to create things like certificates on it. That's a novel thing. Document it. If you're deploying your Docker containers in ECS for the first time, here's a fun tip. When you set up your ECS stack, If you tell it that you want it to start with a single ECS instance of your Docker container, one thing you haven't done when you're deploying the stack is you haven't deployed your actual Docker container instance. You don't have a build up there. So it'll sit there and hang and time out and say, I couldn't create the stack. So there are tricks around that, and you'll document those tricks as you learn them. For example, in ECS, I'm sorry, in the CDK, once you create your ECS container, you can go in, and I'll post a link to this. You can go in and you can manually set it to not deploy anything yet, so that it turns off any instances of Docker as it builds the stack. And then you can manually go in and flip it up to 1 or 2 or 5 or whatever instances is the max. These are weird things. You're going to have to document them. Things like, where do I put my credentials in production? How do I change a database password? Did I turn on password rotation? And if so, how does that work? Document it. Where do I inject my configuration? Where do I tweak it for my containers? Document it. How do I trip a rebuild? Document it, right? All of your things should be documented in some way, every novel interaction. And this is crucial. And don't wait till the 4th sprint to do this. So there's the major deliverables. We'll have our setup and management guide, whatever you want to call it, installation guide. We have a running ECS environment by now. We probably have the front end as well replicated at least in S3 for a web bucket, or probably, because you're going to go in production with CloudFront, you'll probably set up a CloudFront distribution. And the CloudFront distribution can give you that /API shortcut. So you're probably going to want to run your web front end on CloudFront and S3. You'll have the beginning of a running CodeBuild CI environment. By the way, guess what runs great in CodeBuild? Flyway migrations, right? You can use CodeBuild to trip off your migrations. So every time you have database schema change and you push new stuff up to the cloud, you can trip your CodeBuild and say, please update my schema. So that's the kind of thing you'll do with CodeBuild. The other thing that runs great there is API calls to set up your application users and things like that, test data. You can run those from CodeBuild because you're inside the VPC. By then, you'll have feature 2 completed and features 3 and 4 in a demoable state. This may not match reality, but it might. Are you in production and rounding the corner on feature completion? Great, you're on time. But this could take 12 weeks. This could take 20 weeks. It depends on how big your app is and what you're doing. These are just general guidelines of sequences of things to do and when. Sprint 4 is really quick. I know we're running up to the 1 o'clock time frame, but we're pretty much done now. So the important things in that, we're wrapping up features 3 and 4. If we have resources available, and sometimes you'll get one UI developer freed up, or your infrastructure developer is done, they can set up UI tests, right? They can set up web tests with a tool like Cypress or Selenium. But I would highly recommend Cypress if you haven't used it before. A fantastic web testing tool. And you can run Cypress from CodeBuild, and we do that. So that's very possible. You can begin your end user testing of the features if they haven't done it already. And now this is also time for you to tune the platform, see if you can blow out your connections, and if so, tweak what you need to keep it running. Make sure as it scales, it starts up more Docker containers. So this is the time to do that kind of work. And you have benefits of using configuration as code like Terraform or CloudFormation or CDK, because you began the project with that. And you set up your application stack with code. You've externalized your environment variables. Your developers built their code in Docker. They could focus on Docker, not get tied up with weird AWS issues. Meanwhile, Docker in the cloud works like Docker locally. So when it does go to production, developers can look at it and help you with it. They can look at their logs and they can get a feel for what's happening. Your CI effort is going to use CodeBuild, and that means you've got an ability to trip different features that you've built. And so in the end, containers make it easier to work with cloud development. And so I just want to point out briefly here, please don't forget the things like the logging and the monitoring, and also make sure you put CloudWatch alarms and other monitors on your services like RDS and your containers. You should know when you're starting to spin up multiple containers. Maybe you're being hacked, or maybe it's just a natural, process. You should put limits on resources if possible to make sure you don't get someone running away and hacking your system and causing you a large bill. So these are the kinds of things you start getting in place as you go closer to production. Again, your app isn't ours. This is just relative timings. And you don't have to use ECS for this. You can try EKS. You can even try Lambdas. One of the things that Amazon has announced, and we talked about this in our Tech Chat Tuesday yesterday, is they've announced Docker containers for Lambda. And they're really looking at like finding ways to run all this stuff more easily locally for you to debug. Before that, I was using some of the Lambda CIs, Lambda container. But that's different workflow. This is just talking mostly about containers as Docker. And you don't have to use SPAs. We have projects that use something like Next.js, which is mostly server rendered, or Gatsby for content rendered sites. Or you could use just plain old websites without a front end, that's single page app. It could be, a Django application. You don't need the SPA part. And that suddenly cuts off a lot of the complexity. So sometimes you don't need a single page app. Maybe you just need a web app. All right. So again, look into these things, take a look and see what you think. Hopefully this has been useful. For feedback, please email me. I'm krimple@chariotsolutions.com. You can hit our blog up for a ton of content, a lot of good technical discussions. You can look up all of our video sessions going way back to 2012 and earlier in some cases, from emerging technologies for the enterprise, and other shows like our single page app show and our IoT and AWS show. They're all free. They're all online at youtube.com/Chariot Solutions. And look forward to seeing us at ETE 2021. That conference will happen. If you look at phillyemergingtech.com in about a week or 2 or 3, you'll see the announcement and you'll be able to do early registration. And again, we're available to help you with AWS. We are an AWS development partner. We do software development and we do, front ends in those different SPA applications. We do mobile applications, and we also do applications on the back end in Node, in Spring, and other technologies, as well as the data engineering. And with that, I appreciate your attendance, and let me take a look and see if there's any questions in here. Looks like there might be. Just looking here real quick. Someone mentioned Tailwind seems to have some buzz as a CSS framework to use. I've heard of that too. Yeah, definitely take a look at what's out there. Every couple of years, there's a new one that seems to get a little bit better to work with. But thank you very much for attending. We really appreciate it.